Hello students, in this video we are going to discuss signed binary number. So why we are using this signed binary number? So in order to minimize the usage of hardware, so we are using the signed binary number representation to perform addition, subtraction, any binary arithmetic operations. So first we will discuss how to represent the signed binary number. This is the general format. Okay, so here I have taken 8 bits, right? So 1 2 3 4 5 6 7 8, it is a 8 bit, right? So the MSB, this one is the LSB, least significant bit. This one is a MSB, most significant bit. So entirely the signed binary number defined by based on the value of MSB bit, right? If the MSB bit is 0, the result is positive. If the MSB bit is 1, then the result is negative. The except the MSB bit, the remaining bits are magnitude bits. So we will take one example. We will discuss how to represent the signed binary number. So here 25 is a decimal number. So you know very well how to convert decimal to binary. So by using a divided by n method, you have to convert the given number 25 into a binary number, right? So then this is a binary representation of 25. Okay, so as it is a 8-bit binary, we need to represent the number in 8-bit in the especially while performing the binary arithmetic operation, right? Binary arithmetic operation using the signed binary number bits, right? So it should be a 8-bit binary. This is the condition. Sometime you will get the question, why should I have to represent the number in the form of 8 bits? Because in order to find out whether the given number is plus or minus, compulsory you should have to represent the given decimal number in the binary as a 8 bit, as a 8 bits, right? So the positive decimal number 25 we can represent using 8 bits like this, right? So just you have to add 3 more zeros here in order to make 8 bits. Okay, so now as it is a positive 25, right, plus 25, so the MSB bit is 0. So I want to convert this plus to minus 25. So I have to change 0 to 1. Then our result becomes minus 25. So we can also convert our positive number to negative number using a other two methods. One is a ones complement method, another is a twos complement method. See, you know very well what is ones complement and twos complement. Ones complement means just you have to inverse the value of positive number. Whenever you have 1, it changes to 0. Whenever we have 0, it changes to 1. Right? We have to make invert operation for the entire binary length. After that, we will get this result. Here, as the MSB bit is 1, so the result is minus 25. The result is in the form of 1's complement. Right? So, if it is 2's complement, see here. So, how to convert the positive number plus 25 to negative number using 2's complement, we will discuss here. This is the representation of plus 25. You know very well it is a 8-bit representation of plus 25. Now, I want to convert this plus 25 to minus 25, isn't it? So, using 2's complement method. So, how to convert? First, you have to perform ones complement, right? You have to perform ones complement, which means you have to convert whenever you have 1, it becomes 0, right? It becomes 0. Whenever you have 0, it becomes 1. It becomes 1. See here, it becomes 1. It is the first step. You have to take ones complement for the given positive number. Later, you have to add plus 1 with the result. Then it becomes minus 25. So after adding 0 plus 1, it becomes 1. So the remaining bits you have to keep as like that. So now the result is minus 25. So in this way you can perform the or you can convert the positive number to negative number using a ones complement method and twos complement method. You can easily convert the given positive number to negative number. Okay, so now we will discuss one problem based on this. So especially where we are using the signed binary number in the subtraction only, right? It may be the number, it may be an first number, or the number may be in the second as a negative, right? We will discuss. So here we will discuss two conditions. I mean, in two different ways we can solve the problems. In the first condition, subtract smaller number from larger one. The next one is subtract larger number from smaller one. Okay, so see here, this is the subtract 1001 from 4 ones using ones complement method. Using ones complement method, see here, you have to subtract this number with the 4 ones. Okay, so the first number is 15, the second number is 9, right? So you have to subtract 15 with the minus 9. See here, so this is your signed number, this is the positive number. You know how to represent the positive number. So all the 4 bits should be 1. So in order to get 15, all the 4 bits should be 1. So in order to get 9, all the first, the MSB bit should be 1 and the first bit should be 1, right? 8 plus 1, this one is 8, this one is 1. 8 plus 1, 9. Now we will discuss how to perform the subtraction operation using ones complement, right? So before going to that, first take the ones complement for the signed number 9, minus 9, right? How to take that? So just you have to do inverse operation, right? So 0, 1, 1, 0, right? So then you have to add plus 15 with this 9, right? So ones complement of minus 9, right? So see here, 1 plus, you have to add 1 plus 0, the result is 1, 1 plus 1, so the result is actually 1, 0, right? So this is the representation of decimal value 2, right? So you have to keep this one as a result, first bit, right? So this one is the carry bit, this one is your carry bit. So 1 plus 1, the result is 1, 0. 1, 0 plus 1, the result is 1, 1, right? So you have to keep this first bit as a result, the second bit as a carry. So 1 plus 1, the result is 1, 0, right? So then what should we have to do in the ones complement method? So if you are getting the carry, extra carry bit, so this is the rule. This is the rule in the ones complement. So if you are getting the extra carry bit, you have to add that extra carry bit with the result. In the ones complement, if you are getting the extra carry bit with the result, you have to add that extra carry bit with the LSB of the result, right? So if doesn't exist, what should have to do? If doesn't exist, you have to take the ones complement of the result. Just you have to do invert operation with the result when if the carry doesn't exist. here carries exist. So you have to add this 1 with the LSB bit. So 1 plus 1, the result is 0, carry 1. 1 plus, so here this is a plus operation. So you have to return this 1. So 1, 0. So what is the decimal value of this binary number? Is a 6. So the decimal subtraction and the binary subtraction results are same. Right? So now we will discuss another problem, right? Subtract smaller number with the larger one, right? Using ones complement method, right? So 15 minus 28 in the decimal value, the result is minus 30, right? You know the positive value of representation of 15, 0, 4 ones. So the positive value here, the second number is a signed number. It is a unsigned number. This one is a signed number. So now I have to use ones complement to convert signed number, right? So first you have to represent 28 with the positive number. So right, this is the positive number. Then you have to convert into as a negative number using a ones complement. What should I have to do? You have to take complement, I mean invert operation. So whenever you have 1, you have to replace with the zeros. Whenever you have zeros, you have to replace with 1, right? Then you have to take this result, then you have to add with the first number 15, right? So 15, 0, 4 ones. This is the ones complement of 28, right? So then you have to add the result. 1 plus 1, the result is 0, carry 1. 1 plus 1, the result, 1 plus 1, the result is 1, 0. 1, 0 is added with 1. What happens? 1, 0 is added with 1. You will get 1, 1. So you have to keep this one here. This one is a carry bit. So again 1 plus 1, the result is 1, 0, right? You have to keep this as a result. This one is a carry bit. So 1 plus 1, the result is 1, 0. You have to keep it this result and you have to take this one as a carry bit. Here no carry exists. What is the rule? If carry exists, you have to add that 1 with the LSB. Here there is no carry, then you have to take the ones complement for the result. You retain this MSB bit because it is a negative sign. You have to take the magnitude ones complement. What it becomes? So double 1. See, 1, 1, 0, 1. So this is the, keep it this one. Okay, don't do the invert operation for this, right? This is the sign bit, right? So here 8 plus 4, 12, 12 plus 1, 13. So the result is minus 13 in the binary number. So here in the decimal subtraction also we are getting minus 13. So this is ones complement operation. Now we will discuss two's complement arithmetic operation, right? Two's complement based arithmetic operation. So here mainly we are using the two's complement for subtraction, right? So here I will discuss one problem. So you know the representation of 46, right? So this is the 46 binary number, right? So decimal value of 46 and its binary number, right? So I have to take 2's complement for minus 14. So where should I have to take 2's complement for the minus 14? First, what should I have to do? First, you have to represent plus 14. You have to find out the binary value using a divided by n method. Using divided by n method. Okay. So then you have to take 2's complement. You have to take 2's complement for plus 14 value. I mean, so you have to take 2's complement for binary number of plus 14, right? So what is the first step? First you have to do invert operation. You have to do ones complement. You have to do ones complement. For the 2's complement, you have to add plus 1 with the result. You have to add plus 1 with the LSB bit. You have to add plus 1 with the LSB. This is the rule. What is the rule? In the 1's complement, just you have to perform invert operation. You have to perform invert operation. Okay, which means whenever you have 1, you have to replace 0. Wherever you have 0, you have to replace 1, right? So in the 2's complement, what is the how to convert the given number into 2's complement? So first step, you have to take 1's complement, right? The second step, with the LSB bit, you have to add plus 1. See here, first I have taken the complement of plus 14, right? This is the invert operation of plus 14. This is a 1's complement. Then in the LSB, I have to add plus 1, right? So then you will get this result. 1 plus 1, the result is 0. Carry 1, you have to write that carry here. The remaining as it is, you have to write, right? Here there is no values, not to perform addition. So I am replacing like that. Okay. So this is the 2's complement value of 14. So this is the minus 14 representation. Now you have to add 46 with this number. So this is the plus 46. This one is the minus 14, right? So after adding plus 46 with the minus 14 with this result, so you will get 32. The result is 32 because this is a plus greater than first number is greater than when compared to second number, right? What is the second number? The second number is minus 14. So our result is positive value, right? So in the 2's complement, please listen carefully. In the 2's complement, if the carry exists, so you have to ignore that carry. If the carry exists, you have to ignore the carry. If the carry does not exist, you have to take the 2's complement for the result, right? Here I am getting the carry, so I have to omit this carry. So just you have to find out the decimal value of this binary number. So after performing the addition operation, you have to find out whether are you getting extra carry bit or not. If you are getting the extra carry bit, you have to ignore. If you are not getting the extra carry bit, you have to take the 2's complement for the magnitude. So your result is plus 32, right? So you are I think you are able to understand this concept. So please note down the rules for the 1's complement and 2's complement, how to convert the given number to 1's complement, how to convert the given number to 2's complement. And then, so while performing the addition operation, the rules are different for the 1's complement and 2's complement. For in the 1's complement, if carry exists, what should you have to do? You have to add with the result in the LSB. If the carry does not exist, you have to take 1's complement. In the 2's complement, if carry exists, you have to ignore. If the carry does not exist, you have to take the 2's complement with the result. Thank you.